So today we are going to look at the cross product in vectors. Cross product in vectors. So just like the other week we looked at, the other week we were looking at dot product. We saw how a dot product can be obtained given two vectors. So in this case again, today we are going to look at cross product. In this case, if you are given two vectors, how do we get a cross product? A cross product between two vectors can be noted by A cross B. So if you are given two vectors A and B, then if you want to represent a cross product, then this is read as A cross B, which denotes a cross product between two vectors. And a cross product between two vectors will result, this will result in another vector. It will also give you another vector quantity. It will result in another vector quantity. So if you look at what we did last week in dot product, we said that the dot product between two vectors A dot B, this one will give you what we call a scalar quantity. So the difference between dot product and cross product is that in dot product we get a scalar quantity or just a number, but in cross product we get another vector quantity. So I want us to see today how can we obtain what we call a cross product. So if you are given two vectors, vector A, which again is A1I plus A2J plus A3K, and another vector B, which is equals to B1I plus B2J plus B3K, then we can obtain what we call, we can actually find A cross B, which we can obtain as follows. So if you have two vectors and you are going to get the cross product between the two vectors, then the cross product between two vectors A cross B is always given by the determinant over 3 by 3 matrix. So the determinant over 3 by 3 matrix will give you the cross product between those two vectors, which can be solved as A cross B is given by the determinant, you get the determinant over 3 by 3 matrix. But the elements of this 3 by 3 matrix that will be inside there are going to be as follows. The first row, so this is the determinant of a 3 by 3 matrix. 3 by 3 matrix. But now, a 3 by 3 matrix is a matrix which is having 3 rows. So the first row is going to be formed by the elements I, J, and K. So I, J, and K will form the first row. So I, J, and K. This is going to be the elements, this is going to give you the elements of the first row. So the first row is usually formed by the elements I, J, and K. Then the second row is formed by the elements of A, of matrix A, the first matrix in this cross product, A cross B. So the first matrix A, the elements of this matrix A will form the second row of the 3 by 3 matrix. And the elements of A are A1 in the I direction, and A2 in the J direction, and then finally A3 in the K direction. So we can simply put them in this row as A1 will be under I, A2 will be under J, and then A3 will be under K. Then the last row in the 3 by 3 matrix is going to be formed by the elements of matrix B of vector B. But vector B, we are told that we have B1 in the I direction, B2 in the J direction, and then finally B3 in the K direction. So we can simply place them here as B1 will be under I, B2 will be under J, and then B3 will be under K. If we get the determinant of this 3 by 3 matrix, we will have found what we call the cross product between two vectors. So I want us to look at a relevant example and see how we can find the cross product between two vectors. So in this case, I want us to take a look at this example, and we're only going to look at one example and see how to evaluate up to the last step of getting the cross product. So in this case, we are given two vectors, vector A, and this vector A is given by 2i minus j plus 4k. Vector b is given by 3i minus 9j plus 18k. So in this case, we are given those matrices, those vectors that way, and we want to determine the cross product between these two vectors. And as we have said, that a cross product between two vectors A and B is always given by the determinant of a 3 by 3 matrix. So we have to form the 3 by 3 matrix. This matrix must be 3 by 3, the matrix whose determinant we want to determine. But we said that whenever we want to get the cross product, the first row in the 3 by 3 matrix is formed by the elements I, J, and K. Then the second row is formed by the elements of the first vector. In this case, the first vector is A, vector A. So the elements of vector A are going to be fed below to form the second row. But now, for the elements of A, 2 is along I. So 2 will be along I, negative 1 will be along J, and then 4 will be along K. Then the third row is going to be formed by the elements of vector B, and the elements of vector B, 3 is along I, negative 9 is along J, and then 18 is along K. Then now what is remaining is to find the determinant of this 3 by 3 matrix. If you get the determinant of the 3 by 3 matrix, we will have found what we call the cross product between two vectors A and B. So how do we go about it? Whenever you want to find the determinant of a 3 by 3 matrix, the determinant of a 3 by 3 matrix is given by the top row. This top row is the one that is going to help us in getting the determinant of a 3 by 3 matrix, which in this case, we give them signs. If you want to get the determinant of this, we give the elements in the top row signs, starting with positive. Then we interchange that is positive, negative, positive until we reach the last element. So that is, for example, this one will be positive, the second one will be negative, and then the last one will be positive. So we start with positive, we go to negative, then we go to positive. Then from there, we can now find our cross product between two vectors as follows. So when we want to get the determinant of this 3 by 3 matrix, we get to have positive I, so we get to have positive vector I, then times the elements that will remain when you close the row and the column where this I is. I is in this row. So when you close that row and you close the column and the row. So the row, when you close this one and you close this one, the elements that will remain will be negative 1, 4, negative 9, and 18. So that one now we are done with I. Then you go to minus J. So minus vector J. But then vector J again, you get the determinant of the elements that will remain when you close vector J. So when you close vector J, the row and the column, J is in this row, but it's in this column. So when you close that, you are going to remain with 4 elements, 2, 4, 3, and 18. And then the last one will be positive K. So if you take positive K, again, you close the row and the column where positive K is. So the row and the column where positive K is in this row. So when you close that and you close the column, then you are going to remain with 2, negative 1, 3, and negative 9. So this is now going to give us 2 by 2 matrices. 2 by 2 matrices. And if you have a 2 by 2 matrix, you can be able to get the determinant of a 2 by 2 matrix as follows. This will give us now positive I. But now, for a 2 by 2 matrix, the determinant of a 2 by 2 matrix is given by, you multiply the elements along the main diagonal, then you minus the elements along, the product of the elements along the second diagonal. So this is our main diagonal. We'll multiply the elements, that is negative 1 multiplied by 8, then you minus the elements along the second diagonal. In this case, will be, you take negative 9, you multiply 4. So that is how we get the determinant of a 2 by 2. Then the same to this will be minus J. Then we do the same. This is the elements along the primary diagonal is going to be 2 multiplied by 18. Then you minus 3 multiplied by 4, which is in the second diagonal. Then we do the last one. It will be plus K, and K again the elements along the primary diagonal will be 2 multiplied by negative 9, then you minus 3 times negative 1. 3 times negative 1. Then we simply solve, and that answer that we obtain will be what we call the cross product between those two vectors. So if you look at negative 1 times 8 will be negative 8. Then you minus negative 9 times 4 will be negative 36. Then minus j again into 2 times 18 is 36. You minus 3 times 4 is 12. Then you plus k into 2 times negative 9 will be negative 18. You minus 3 times that will be negative 3. Then we simply solve what is in bracket, so that now we find the final answer for our cross product. So you can see that the cross product between A and B in this case will be positive I into negative 8, you minus negative 36. So minus will be plus 36 in that case. Then we have minus j into 36 minus 12 will be 24. Then finally plus vector k into negative 18, you minus 3, so that will be plus 3. Then the final result of A cross B will be found as follows. So this one will be negative 8. If you add to 36, that will give you 28. Then now it is along I. So that will give you 28. 24 times this will give you negative 24. J, and then the final one, negative 18 plus 3 will give you negative 15k. And this is now what we call the dot product of the two vectors. Not the dot product, but the cross product of the two vectors. And as you can see, it gives us another vector I, j, and k. 28i minus 24j plus 15k. So it gives you another vector. This results in another vector quantity. So it gives you another vector.